Solve the system of equations graphically. Determine whether the system is consistent or inconsistent. If the system is consistent, state whether the equations are dependent or independent. We have the system 2x minus 6y equals 2 and negative 3x plus 9y equals negative 3. Let's graph the first one by finding the x and y intercepts. For the x-intercept, we set y equal to 0. But 6 times 0 is 0. So we would have 2x equals 2, and therefore x equals 1. For the y-intercept, we set x equal to 0, but 2 times 0 is 0. So we would have negative 6y equals 2. We divide both sides by negative 6, and we get, y equals negative 1/3. So let's graph those 2 points. X-intercept 1, y-intercept negative 1/3, and we draw our line through those 2 points. Let's take this equation and move down a little bit. We want to find the x-intercept. That means we set y equal to 0. 9 times 0 is 0, so we have negative 3x equals 3. Equals negative 3. So now we divide both sides by negative 3, and we get x is equal to 1. To find the y-intercept, we set x equal to 0. 3 times 0, or even negative 3 times 0, is 0, so we have 9y equals negative 3. We divide both sides by 9, and we have y equals negative 1/3. Well, interestingly enough, these are the same intercepts as our first equation, which means when we draw this line through those intercepts, we get the same exact line. In this particular case, that means every solution that works for the first equation will also work for the second equation. So the way we write that solution is x comma y as an ordered pair, such that, and we just need to take one of these equations and write it there. Now, notice in this equation, we could divide each of the sides by 2. So the 2 would cancel here. This would become a negative 3. And the 2 here would divide by 2 to become 1. So we would have x minus 3y equals 1. So that's how we write our solution for this system of equations. Now, in this particular case, since we have a solution, the system is consistent. The equations in this case, because they are the same, are dependent.